The last setup we would like to talk about is example 6, the photocell. You will be given an Arduino board, a photocell, an LED, a 220 ohm resistor, a 10,000 ohm resistor, a breadboard, and 7 jump wires. From the connecting diagram, you can see that this setup is very similar to example 5. However, the push button in example 5 is replaced by the photocell in example 6. A photocell is also known as a light-dependent resistor. It is a variable resistor which can change its resistance according to the light available to the photocell. For the photocell, the darker it gets, the higher the resistance, and therefore the more light falls on the photocell, the lower the resistance of the photocell. Therefore, by detecting the resistance of the photocell, the setup can detect the amount of light surrounding the setup. Although this setup is similar to example 5, note that because the Arduino board is needed to detect the changes in voltage, therefore the photocell is actually connected to an analog pin, A2, instead of a digital pin. The pictures on the left shows that when the photocell is not blocked and there is light shining on the photocell, because of the low resistance of the photocell, the LED is programmed to be switched off, while when the photocell is blocked by a finger and there is no light reaching the photocell, the resistance on the photocell will be high, and the LED is programmed to switch on when there is no light on the photocell. Here, you are shown the schematic diagram illustrating this setup. The photocell is connected to the 5-volt pin and also to the A2 analog pin. This allows the Arduino board to detect the variable resistance of the photocell and therefore detects the light intensity surrounding the setup. The photocell is also connected to a 10,000 ohm resistor and then connected to ground. Separately, the LED is connected to the D13 digital pin and a 220 ohm resistor, and the circuit is connected to ground to complete the circuit. The code here is the sketch for example 6. From the code, we can see that the analog pin A2 is used to read the voltage from the photocell, therefore meaning it's reading the resistance from the photocell, while the digital pin D13 is used to turn on the LED or turn off the LED at different situations. The photocell therefore acts as an analog input. If you want to read the value of the photocell and therefore the constant changes in voltage from the photocell, you can check the values by going to Tools and then Serial Monitor. If you click that, a new window will show up and then there will be numbers keep on showing up. These values are the values that is sensed by the analog pin. If you put your finger onto the photocell and then lifting your finger away from the photocell, the values should change. This indicates that the photocell is working properly and your setup is correct. By going through these 6 examples, you should have a basic understanding on how to wire Arduino projects. However, Arduino projects are not limited to these 6 examples. Actually, there are many projects that you can attempt, or even invent your own Arduino projects. A few examples that Arduino projects can be used are Arduino weather station, automatic garden watering, ebb and flow aquaponics for the office, simple Arduino controlled aquaponics system, Arduino robot, DIY RFID door lock, and many more. With an Arduino and some programming skills, you can create your own projects and express your creativity. Now, let us talk about how the Arduino board is related to the Chinese Mitten Crabs aquaponics project. In our school, we have the Chinese Mitten Crabs aquaponics room. We are raising Chinese mitten crabs in that room. Every day, student helpers have to go down to the room and feed the crabs by hand. This is quite a tedious process. Therefore, we can turn the feeding into an automatic process. By using an Arduino board and with suitable programming, we will no longer need to feed the crabs by hand. We can do this by connecting an Arduino board to a servo motor. A servo motor is a motor that can be controlled using an Arduino board that is programmed properly. If we program the Arduino board and command the servo motor to turn at suitable time periods and turn a suitable amount, and then we connect a feeding mechanism onto the servo motor. When the servo motor turns, it will drop food pellets into the crab tank. Therefore, by programming the Arduino, we can control when and how much the crabs are fed. In the future, we will only need to refuel the feeding mechanism once per week, reducing the amount of times student helpers have to visit the room and feed the crabs by hand. Furthermore, we can do another Arduino project by connecting an Arduino to a water wheel. When the water wheel turns, it will send information to the Arduino board. Therefore, we can detect the rate of water flow from the vegetable bed into the crab tank. This can act as a sensor to monitor how the water is siphoned from the vegetable tank into the crab tank below. In the future, the school might purchase Arduino boards that can connect to the internet. Therefore, the data detected by the Arduino board can be uploaded onto the internet, and therefore we can monitor the water flow anywhere in the world. Furthermore, in order to promote growth for our vegetables in the vegetable tank, we can turn on LED growth lights onto the vegetables during the night. This allows 24-hour photosynthesis and therefore can increase the productivity of the vegetables and decreases the growth time so that we can harvest earlier. However, we do not want to turn on the LEDs during daytime, as sunlight will be shined into the room through the windows of the aquaponics crab room. If we turn on the LED lights at the same time, we will be wasting electricity and therefore wasting money. Therefore, consider example 6 of our previous Arduino project example. It is a setup with a photocell. When the photocell does not detect light, the resistance is high. This will be detected by the Arduino board through the analog pin, and it will turn on the LED. Using the same concept, but we will connect LED growth lights instead. Therefore, the growth lights will only turn on when the room is dark, and therefore we will not waste electricity, and this can reduce our expenditure.
This is the end of the video. Thank you for watching. Please give us a like and subscribe to our channel. We'll see you next time. Bye bye.